channel. We're looking at linear equations. We're looking at questions on linear equations. And we have this question. The straight line L1 passes through the points A, which is 1,1/3, and B, 4,4/3. Find the gradient of line L1. The second one show that line L1 also passes through the origin 0,0. So let's look at the first part of the question. We are told to find gradient here. Gradient has this formula, which is changing y over what? We're changing x. And changing y will be what? Y2 minus what? Y1. And changing x will be x2 minus x1. So let's check the coordinates we have. We have these coordinates for A, 1,1/3, and then we have B coordinates, that's 4,4/3. So in this case now, this will be x1, and this will be what? Y1. Coordinate is x, y. So this will be x2, and this will be y2. So let's plug in those values. So the gradient will now be equal to what? The y2 is what? 4/3 minus y1 is 1/3 all over x2 is 4, and then x1 is what? Is 1. So we have this. So we're having 1 on the numerator, and at the bottom 4 minus 1, that's 3. So that's gradient. The B part, we are told to show that line L1 passes through the origin. What we are going to do in that case, we are going to find the equation of a straight line. We can use this equation. The equation of a straight line has many forms. So let's take this form. And we can use any of the points. We can use point A, we can use point B to solve this equation of a straight line. So I'm taking point A. So that will be equal to y minus y1 is what? That's 1/3. My gradient is 1/3. My x1 is 1. Okay? Can we multiply all 2 by 3? So if you do that, we're going to have 3y minus, this will be what? 1 equal to x minus 1. This one to other side. So we have 3y equal to what? Equal to x. And to now show that the line L1 passes through the origin is very simple. Let's do that. Let's show 0,0. When x is 0, put it in this equation. When x is 0, y will be what? Y will be 0. When x is 0, substitute into this place, so y is 0. Therefore, line L1 passes what? Passes to the origin. So that's what we are told to do here. Just get your equation with a straight line and then confirm if these are points pass through that. Okay? So if you substitute for x, you get y also as 0. The second part of the question, the straight line L2 is perpendicular to L1 and passes through the points 2,6. Give the equation of line L2 in this form. So what we need to do, the first thing we have to do first is to get the gradient of the perpendicular line. Okay? The gradient of the perpendicular line, that will be M2 equal to what? Minus 1 over what? Over M1. Okay? And then that will give us what? Minus 1 over my M1 is what we got here, 1/3. Okay, so this will give us what? Minus 3. So that's the gradient of the perpendicular line for L2. So then we have the point 2,6. We can start using that. And then our equation must be of this form. So we can start out. So y is what? Y is 6. When x is what? When x is 2. My gradient is what? My gradient is minus 3 times 2 plus c. This is 2 times this, that's minus 6. Move it to the other side. So c is what? C is 12. So on that part now, the equation of the L2 will now become y equal to, the gradient is minus 3. Then the intercept, the y-intercept is 12, that's a plus 12. So we have done what we are told to do. So that's that on that equation. So this is for L2 and this one is for L1. Okay? Then the last question, determine the x-coordinates of the point of intersection between L1 and L2. And that will be equal to, the first one, this is here, we can make y the subject here. So y is equal to what? X over 3. That's the first one. The second one, we have this. So equate the y. So we now have, that will be equal to x over 3 equal to what? Minus 3x plus what? Plus 12. That will give us x equal to cross multiply. So we have 3 into bracket minus 3x plus 12. So open the brackets. So this will be minus 9x, and then this one times this one, that's a plus 36. So move this one to other side. So we have 10x equal to what? 36. So from here, x is 36 over 10, okay, which is 18 over 5.